So we're going to prove the second trig formula, that's the sine rule. So we want to show that a over sine A is b over sine b is c over sine b, c over sine c. There are a couple of different proofs to this. A lot of them involve looking at different cases of a. So you look at one case where a is acute, you look at another case where a is obtuse, you look at another case where a is 90 degrees. We're not going to do that. So to avoid doing that, we're going to do the following. So we're going to say, given a triangle with sides of length A, B, and C. Alright, we're going to draw it in a particular way. So let's do the drawing first and then we'll write down what we did. So we're going to draw the triangle. So this is, let's say this is the angle A, so this is the side A, this is the angle B, so this is the side B, and this is the side C here. We're going to place it on the grid so that that point there is 0, 0, and so that this line here is on the x-axis. And now we're going to draw a circle that goes through the top point here. So we're going to draw a circle with center at 0, 0 going through that. So in other words, with the radius of b. Alright, so I'll try to draw that. I'm pretty bad at drawing circles, so hopefully it won't look too stupid. There we go, that's our circle. Okay. So let's just write down what we did. So given a triangle with sides of length A, B, and C, we place angle A at 0, 0, okay, and side of length C on the positive x-axis. Okay, the positive x-axis, this is the part, if that's 0, 0, this is the part of the x-axis that's a plus. So that's the positive x-axis. Alright? Now, if you think back to the unit circle, on the unit circle, if b was 1, the coordinates at this point would be cos of A and sine of A, because that's the angle A there. And it wouldn't matter if A was acute, like it is, if A was 90 degrees, if A was obtuse, it would make no difference. The coordinates at that point are always cos of A and sine of A. Okay? What we've done is, if the radius was 2, the coordinates would be twice cos A and twice sine A. If the radius was 3, it would be 3 times cos A and 3 times sine A. If the radius was a half, it would be a half cos A and a half sine A. So if b is bigger than 1, we're blowing the circle out, we're expanding the unit circle. If b is less than 1, we're shrinking the unit circle in. And either way, the coordinates at that point up there are b times cos of A, is the x coordinate, and b times sine of A. So b cos A and b sine A. Just about fits in there, kind of a squash. Alright? So the top vertex has coordinates b cos A, comma, b sine A. From the unit circle enlarged to radius b. Alright? So what that means is that the height, the perpendicular height, so the perpendicular height of the triangle with C as base, because I suppose if you're talking about the perpendicular heights, you have to say which base you're using, really, technically. So with this side as a base here, the perpendicular height there is just the y coordinate at that point. Is the y coordinate tells you how high up the point is. So the perpendicular height of the triangle is b sine A, because that's the y coordinate. Alright, and we're going to put a box on b sine A. That's important. Okay. There's almost no working out in this proof. It's just to remember the two pictures and to remember what you did to get the two pictures. So one way we do it is we put the triangle in. What we're going to do now is we're going to redraw the exact same triangle, pretty much the same way. So still with C at the base, with A here, B here, and the two sides, A here and B here. But instead of putting the origin here, we're going to put the origin here. And we're going to draw a triangle again, we're going to draw a circle again, going through that top point. And because we've redrawn the same triangle, well, the height of the triangle we have here will be the height of the new triangle we're going to draw. And what we'll do is, the height is the y coordinate, so we'll set the two y coordinates equal, and then we'll have one line of what you call maths working out, and we'll be done. So that's the plan. So we're going to redraw this. We're going to make this the origin. Instead of putting c on the positive x, we'll have c on the negative x-axis, because if this is 0, then these are all the minus numbers on the x-axis, and we'll take it from there. We'll draw a circle. So let's do that. So this is the kind of the second half of the proof. So now redraw the same triangle, okay, but with b at 0, 0 and side length c on the negative x-axis. Okay, so let's see what that looks like. So let's redraw the same triangle. So kind of looks something like this. Okay, so that's A, that's B, so that's A, that's B, this is side length C, but this time this is 0, 0. And now we're going to think of drawing a circle again through the top point, but this time it's got a radius of A. Alright, so this is a bigger circle, so looks like that. Okay, so it doesn't hardly fit on the screen. So that's meant to be a circle, center 0, 0, radius of A. Now, if that's the negative x-axis, then this here is my positive x-axis. So if that's B, this angle is 180 degrees minus B. Alright? And the coordinates at that point up here, well, it's going to be A times cos of 180 minus B, and A times sine of 180 minus B. Okay, because 180 minus B is the angle there. Alright, it's always the angle that it makes with the positive x-axis, so that angle there. Alright, so let's go do the proof. So the top vertex has coordinates A cos 180 minus B and A sine 180 minus B. Oh, oops. So there we go. So the top coordinates has those, top vertex has those coordinates, but A sine of 180 minus B is the same as A sine of B, because the two angles are in quadrants 1 and 2. Alright, if B is acute, it's in quadrant 1, so this is in quadrant 2. If B is obtuse, this is in quadrant 2, so this is in quadrant 1. And either way, sine is positive in 1 and 2. This is just a reference angle for that, so they have to be the same. So what that means is that the height, which is the y coordinate, is A sine 180 minus B, so that's just A sine B. So therefore, I suppose the perpendicular height of the triangle with side length C as a base is, what do we say it was? A sine B. Okay, but like it's the same triangle, so the two perpendicular heights are the same, but perpendicular heights are the same because it's the same triangle. And this is the one bit of maths, so A sine B is equal to B sine A. So now what we can do is we can divide both of them. See, we only want the A and the B on the top line. We don't want the sine B, and we don't want the sine A. So let's divide both of them by sine B sine A. You can leave this line out if you like, if you're happy enough without putting it in. So you can divide by sine B sine A here. You can divide by sine B sine A here. And in this one, the sine B's cancel, and in this one, the sine A's cancel. So I'm left with A over sine A equals B over sine B. And finally, similarly, we can show that we'll say A over sine A equals C over sine C, and therefore A over sine A equals B over sine B equals C over sine C, and we're done. So there was very little maths. The only maths was right at the very end there, where we have to go dividing by sine B sine A. It's a case of remembering the kind of two ways that you place the triangle. In the first instance, you place the triangle, we'll say, with A at the center, draw a circle through the top point, find out what the coordinates are. In the second case then, you place the triangle with B at the center at 0, 0, and again you draw a circle through here. And then the one little trick is to remember that sine of 180 minus B is the same as sine of B, and you're pretty much finished.